Welcome back to Pi Academy. This is my 6th video on sequence. Other videos link provided in description box. Today I will discuss about definition of Cauchy sequence and some important problems. Now the definition of Cauchy sequence. A sequence xn of real numbers is said to be a Cauchy sequence if for any epsilon greater than 0 there exists a positive integer capital N such that mod of xm minus n minus xn less than epsilon for all m comma n greater than capital N. Replacing small m by small n plus small p, we may write the inequality as mod xn plus p minus xn less than epsilon for all small n greater than capital N and for all small p equal to 1, 2, 3 dot dot dot. That is, if the inequality this hold, then we can say that the sequence xn is a Cauchy sequence. Now an important note on Cauchy sequence. A sequence of real number converges if and only if it is a Cauchy sequence. That is, if a sequence is Cauchy sequence, then we can say that the sequence is convergent, and if a sequence is convergent, then we can say that the sequence is a Cauchy sequence. This is an important note. Now I will discuss about some important examples on Cauchy sequence. Question number 1. Show that the sequence 1 by n is a Cauchy sequence. Solution. Let us take positive integer small m and small n such that small m greater than small n, and here xn equal to 1 by n. Therefore, by definition of Cauchy sequence, mod xm minus xn, that is, we have to show mod xm minus xn less than epsilon. Then we can say that the sequence is a Cauchy sequence. Now xm minus xn equal to, here xm equal to 1 by m and xn equal to minus 1 by n. This is 1 by n. Then this is m minus small n by mn. Since m greater than n, therefore this is positive, and it is also positive since it is positive integer, and this equal to, we can write 1 by n into 1 minus n by m. Here n is small and m is greater than small n, therefore the fraction n by m less than 1, therefore we can write this at less than 1 by n. Therefore, for any given epsilon greater than 0, mod of 1 by m minus 1 by n less than epsilon, that is this less than epsilon, if 1 by n less than epsilon, that is if 1 by n less than epsilon, that is if small n greater than 1 by epsilon and small m greater than n. Thus the definition of Cauchy theorem is satisfied, since xm minus xn less than epsilon when n greater than 1 by epsilon. Therefore Cauchy sequence, the definition of Cauchy sequence satisfied, then we can say the sequence 1 by n is a Cauchy sequence. Now example 2. Show that the sequence n square is not a Cauchy sequence. Let us take m and n positive integers such that small m greater than small n. Now xn, here xn equal to n square. We have to show xm minus xn less than epsilon for Cauchy sequence. Now you calculate this mod xm minus xn, that is equal to mod m square minus n square, and this we can write m plus n into m minus n, and this greater than 2n and 2n greater than 1, because n is a positive integer, So whatever n may be, 2n greater than 1. Taking epsilon equal to 1, no positive integer capital N exists such that m square minus n square less than epsilon for all mn greater than capital N. Therefore, by definition, sequence n square is not a Cauchy sequence. Since the definition is not satisfied, therefore this is not a Cauchy sequence. Now, question number 3. Show that yn, where yn equal to 1 plus 1 by 2 factorial, 1 by 3 factorial dot dot 1 by n factorial is convergent. That is, we have to show that this sequence is Cauchy sequence, because we know if a sequence is Cauchy sequence, then we can say that the sequence is convergent. So first we show that this sequence is a Cauchy sequence. We see that 1 by n factorial equal to, we can write 1 by n factorial equal to 1 by 2 into 3 into dot 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 n, and this less than 1 by 2 into 2 into 2. If we replace 2 by 2, 3 by 2 and n by 2, then this is small, and the fraction, the denominator is less than this. Therefore, the fraction greater than this, and this equal to 1 by 2 to the power n minus 1, because here is the multiplier of n minus 1 times of 2. Now we have to calculate mod ym minus yn. Here ym minus yn equal to 1 by, here m greater than n, therefore this equal to 1 by n plus 1 factorial plus 1 by n plus 2 factorial plus dot 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 1 by m factorial, since m greater than small n, and this less than 1 by 2 to the power n plus 1 by 2 to the power n plus 1 plus dot 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 plus 1 by 2 to the power m minus 1, because mod of this lesser equal to mod of this plus mod of this plus mod of this, and we know that 1 by n factorial less than 1 by 2 to the power n minus 1. If we replace n by n plus 1, then 1 by n plus 1 factorial is less than 1 by 2 to the power n, and similarly this and this. Now this is GP series with common ratio is 1 by 2. This is a GP series with common ratio is half, and we know that the sum of the GP series is the formula a into 1 minus r to the power n, that is number of terms, divided by 1 minus r. Here the number of terms is m minus n, and the first term is 1 divided by 2 to the power n, that is a into 1 minus r to the power n. Here the number of terms is m minus n divided by 1 minus r, and since this is 1 minus some positive, then we can write this less than 1 by 2 to the power n into 1 by 1 minus r, and this is equal to 1 by 2 to the power n minus 1. That is, this equal to 1 by, divided by 2 to the power n minus 1. Now since 1 divided by 2 to the power n minus 1 tends to 0, as n tends to infinity, therefore for every epsilon greater than 0, there exists a positive integer n naught for which this less than epsilon, because this is tends to 0 as n tends to infinity. Therefore this is less than epsilon for all n greater or equal to n naught. Therefore we can say that mod ym minus yn less than epsilon for all n greater or equal to n naught and small m greater than small n. Therefore the definition of Cauchy criteria is satisfied. Hence we can say that the sequence yn converges. Now I solve the question number 4. Show that The sequence xn equal to where xn equal to 1 plus half plus 1/3 plus dot 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 1 by n does not converge. That is, we have to show that the sequence xn is not a Cauchy sequence, because we know that if a sequence is not Cauchy sequence, then we can say it is not convergent. Here, if possible, let xn converges, then by Cauchy criteria for epsilon equal to half, there exists a positive integer n naught such that mod xm minus xn less than epsilon for all m comma n greater equal to n naught, because we assume that this is a Cauchy sequence, then it satisfies the definition of Cauchy criteria. We suppose m greater than n and greater equal to n naught, and taking m equal to 2n. Therefore, mod xm minus xn will be mod 1 by divided by n plus 1 plus 1 by divided by n plus 2 plus dot 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 1 by m, that is greater than 1 by divided by 2n plus 1 by 2n plus dot 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 1 by 2n, because 2n is greater than n plus 1 and 2n is also greater than n plus 2 and 2n is also equal to m, because we put m equal to 2n, and this is n times, therefore this equal to n into 1 by 2n, this equal to half. Thus here we put m equal to 2n, because we taking m equal to 2n. Thus mod x2n minus xn greater than half, x2m minus xn greater than half, which is a contradiction, because xm minus xn less than epsilon for all mn greater equal to n naught, this definition is not satisfied. Therefore, the sequence is not a Cauchy sequence. Therefore, the given sequence cannot be convergent. Since it is not Cauchy sequence, then it is not convergent. Thank you for watching this video. Please like, share and subscribe my channel Pi Academy to get more videos.